Ospf troubleshooting. This is also very important for the exam, for real life. Screw the exam, for real life, you gotta know this stuff. You have to know why neighborships, you have to know what can go wrong with OSPF, particularly why certain neighborships do not form, right? So right here we have R1, we have R2, we have R3, nope, this is actually R4. That's R4, and then we have R3. Now, we need to understand and have committed to memory the 8 things that can go wrong with OSPF with regard to neighborships, right? And one of the things, well, I don't want to say one of the things, let's just pull up a list. So some of the things that can go wrong with OSPF neighborships, by the way, let me just pull this over to my screen real quick. This is my Ccna 200-301 Official Cert Guide, Volume 1 ebook. I have the ebook and I have the hardcover. About to say hardcore. Why I keep saying that? Hardcover copy, right? So I marked this book up so crazy that this brings up so many memories. Let's see. I just want to look at this real quick. When did I mark this up? Let's look at some bookmarks. Not even bookmarks. Can I see the, yeah. Look at this. Look at this date right here. Let me go back. Show you guys I was not playing around when studying. This was from this year. Data encapsulation. I was studying all of this. PPP. I was studying all of this stuff. This was from May 3rd, 2021. I was deep in this. March 18, 2021. I was studying for the CCNA for a while. I have a family, so it was a little inconsistent when I first started studying, but eventually I got through it, right? Anyway, let's go back. I forgot where I was. Let me go back over here so that I can pull it back up. Played myself by losing my spot. It was OSPF. And let's see. Yep, there we go. So there's a few things that can go wrong with OSPF, right? So these are the requirements. Interfaces must be in an up state, meaning that both the interfaces between the two routers have to be in an up state. And if you're watching this video, I'm assuming that you already understand subnetting. I'm assuming that you already understand. I'm assuming that you already read everything up to this part right here, right? Let's continue. Access control lists must not filter routing protocol messages. That's something that can easily happen if you misconfigure an ACL by leaving the implicit deny rule at the bottom of the ACL, right? That's something that I've made a mistake with in my home lab, in the simulator. That's something that you have to make sure that you have dialed in. You have to allow those OSPF messages, right? Or however you choose to configure your ACL. Close this right here. Interfaces must be in the same subnet. I'm assuming that you know subnetting and what it requires to have hosts in the same subnet, right? I'm a little bit rusty with subnetting, so I think we might go over subnetting at the end of this lab, right? They must pass routing protocol neighbor authentication if configured. So with OSPF, you can configure OSPF authentication. I need to go over that as well. It's been a while since I've done that. Hello and hold dead/dead timers must match. So hello and dead timers, they're absolutely probably the most important thing, because that's how routers keep track of one another within OSPF. Also in other protocols as well, like HSRP. But routers communicate with each other. Remember, these are intelligent devices. They communicate with each other through these hello messages. And if a router doesn't get a hello message within a specified period of time, the dead timer starts to increment. And within that dead timer incrementation, it increments up to, the default is 40. It increments up, well, the default is 4 times the hello, which is 40. And if it doesn't receive a hello within that dead timer incrementation, it converges, right? Starts making changes. So you can imagine if you have on one router, the hello timer is set to 20 seconds, and on another router, the hello timer is set to 10 seconds. They have 2 different hello dead timer timers, right? With the first one being 20 and 80 for the dead timer, and the second being 10 and 40. So now the first router sends a hello every 20 seconds. By the time the router gets a hello message, its dead timer already started incrementing. So it's kind of like there's a mismatch, right? And that can obviously cause some problems with the formation of neighborships, right? Router IDs must be unique. This is something that's important when the routers are getting to know each other. It's important that a router sees its own router ID towards the end of, I believe it's the two-way state, but it's not supposed to see its own router ID when it's introducing itself to one another, right? So imagine you have, let's use the neighbor analogy. You have a neighbor, right? You live in a nice suburb somewhere in the United States. You just moved in and you say, hello, my name is Dre. And then the neighbor goes, hello, my name is Dre. And you're like, oh, wow, your name is Dre too? So it can kind of take you aback a little bit. You go, oh, we have the same name. And you can form that neighborship. If anything, it would be a conversation piece, allow for you to get to know each other a lot better. But that's not how it works in OSPF. When OSPF router says, hey, yeah, my name is 1.1.1.1, and another router says, yeah, no, my name is 1.1.1.1, they're not gonna get along with each other because these are router identifications. They're specific, unique IDs that's assigned to one unique router throughout that OSPF, I guess area? Yeah, area or process, I believe. I gotta dig into that too more. I gotta do some CCNP study. But yeah, the router ID must be unique, period, right? They must be in the same area. I don't know what just happened. They must be in the same area, right? If they're not in the same area, then you have an issue. Because that's gonna cause some problems with the LSAs and stuff like that, right? OSPF process must not be shut down. Obviously, if you have a process shut down on either one of the routers, there's no OSPF process running, no OSPF neighborships. Simple as that. Neighboring interfaces must use the same MTU setting. So, I guess within the gray, I don't know why it's flickering like that. Let's pull this over here. I guess within the gray, it's more so, is a neighbor missing? If incorrect, no, it's not going to be missing, but it's not going to work properly. In this lab, we focused on aspects of OSPF that, if not configured properly, will cause the neighborship to not form, right? So let's do some investigation. So let's start with router 1. All right, so we have router 1, enable conf t, do show IP OSPF neighbor. So what we see here, and that's a way for you to configure, verify your OSPF neighborships. So what we see here is that we have the router ID 1.1.1.1, priority 1, xstart. It's in an xstart state with the designated router of 172.16.1.2. Well, the address of that interface is 172.16.1.2, right? It's in an xstart state. Why? It's stuck there. It's been, we had the routers on for what, 10 minutes now, and it's stuck in an xstart state. So now we have an issue that we need to investigate. Why is that? So let's go on. Let's investigate this router right here because it's the one that it's connected to. Let's see if they're the first thing. Are they in an up state? We can literally go down this list, right? Is it in an up state? The interface is in an up state. Yes, it's in an up state. But if you're experienced, you would know that if the router IDs match, which is obviously, I just gave it away, it stays in an xstart state, right? But let's go down the list anyway. We see that these G001 interfaces, they're in an up state, right? Let's see if we even have any access control lists configured. Do show IP protocols. Let's see, or do show IP. I think it's IP interface. Yeah, I get those mixed up sometimes. So there's no access lists, right? So let's move on, right? Let's check if they're in the same subnet. Do show run. So the IP address for G01, which is connected to router 2, has an IP address of 172.16.1.1 with a /30 mask. Then we go over to router 2. Let's check that same thing. Do show run. And we see that, yes, they're in the same subnet. Also, we can check the access lists over here too, if there are any. Do show IP interface. And we see no access lists are set, right? What else do we need to check? Okay, they're in the same subnet. They must pass routing protocol neighbor authentication. We don't have any of that here. And if my memory serves me right, we didn't configure any OSPF authentication as well for either one of these routers, right? Hello and dead timers must match. Let's check. And how do we check that? Do show IP OSPF. Let's check. Gotta remember these show commands. Is it do show IP OSPF? Let's do a question mark. Do show IP int OSPF? I forgot which one allows for you to check the... Oh, it's right here on my right. Let me see. I think I can check with show... I just typed that in, didn't I? Do show IP OSPF interface. Oh, I had it backwards. Do show IP. I knew I wasn't forgetting it totally. I knew it was interface something. OSPF int. So I typed in the long form command for that is show IP OSPF interface. So now this is where all the action is. This gives you a lot of information. So where's the hello and dead? So the hello and dead timers. So hello is 10, dead is 40. Do show IP OSPF int. Hello and dead timers match, right? But we notice, and I'm not gonna go down this whole list. This is ideally how you wanna approach this type of problem. When you get it in your practice exams or you know, wherever you're trying to figure this out and troubleshoot it, you want to go down the list of things that could be causing OSPF to act up. We noticed R1 and R2 has the same router ID, and that's what's keeping it from forming the neighborship. And if we check do show IP OSPF. Is it neighbor? Yeah, I think it's neighbor. Neighbor. We see that it's stuck in an Xstart state, and I believe it thinks that it's the other router is the DR. So all we need to do is let's change the router ID, and how you do that is router OSPF1 router ID, and then we can do, I don't know, let's do 8.8.8.8. Keep in mind that these are not IP addresses. They're not IP addresses. They're router IDs. They're 32-bit router identifications, right? So we can do clear IP OSPF process. I guess this has to be done in config mode. Clear IP OSPF process. Am I spelling something wrong? Am I doing something wrong? Let me see. I didn't have lunch yet, so. Oh, wait. Do clear IP OSPF process. Yes, there we go. Reset all OSPF processes. Yes. Yeah, so that just tells you this command needs to be done in privilege exec mode or enable mode. So now let's see. Loading to full, loading done. All right, so we're in enable mode, we're in global config mode. Do show IP OSPF neighbor. Now it's all good, right? So it's saying the neighbor ID is 1.1.1.1. It's in a full state, and I believe this right here means that it's in the neighboring router is a BDR. I believe that I need to brush up on as well. So I'm identifying aspects of OSPF that I need to brush up on too, which is totally fine. You're not gonna know everything in IT ever. You're gonna know a good portion of it to be functionally competent, but you should always be refining your skills by doing these type of labs, right? So now we're gonna do show IP interface. Can I do show IP int? Yeah, I like using the, oh, why did I do that? Oh man, I copied and pasted my my Twitch announcement into the command line. That's funny. So was I looking for that? Which one was it? No, it was do show IP OSPF int. It's time to eat. All right, so this will give us more insight into the last show command we just did. So we see here, and again, this is a very important show command that you need to know for the exam. I'm telling you, if you're doing CCNA, very important that you know this show command. Router ID for the local router is 8.8.8.8. The G01 IP address is 172.16.1.1. Area 0, right? Cool. Router ID, right? We know that already. The network type is broadcast. They must be the same network type also, I believe, for them to work correctly, right? Yep, that's one of the checklists. And that's basically what it is, right? So let's see. Backup designated router is 1.1.1.1. Yeah. So that show command that we did just now, it means that the neighbor ID that it has a neighborship with is 1.1.1.1. This is priority 1. It's in a full state with it, and that neighboring router is a BDR. And you can confirm that again by issuing the do show IP OSPF int or the show IP OSPF interface command, right? So we fixed that. This has a successful neighborship, and the issue that we fixed was duplicate router ID, right? Now, let's check again, because there's another issue going on. It's saying that the neighbor is G01. There's something going on here, right? So let's do show run. Let's check our running config. So we know that, wait, oh, oops, nope, that's not even, no, that simply meant G01, that simply meant I had to stretch it out. So as we can see here, these two routers are supposed to be neighbors, but they're not. I thought that was some sort of telltale sign, but these two routers are supposed to be neighbors, but they're not. We need to find out why. So we know from this checklist that both of these interfaces, they're in an up state, right? We know that there's no ACLs filtering messages here. So let's check here. And how we check for ACLs, once again, is enable conft do show IP int. There's no interfaces set on this router at all whatsoever. So the interfaces, are they in the same subnet? We know what the other router's IP address is. And we know, oops, went too far up. So G0, which one are we doing? G01, right? Because it's this subnet. This is 4.1. Let's check over here. Do show run. Did I even set one for here? Yeah, this is 4.2. So they're in the same subnet. There's no OSPF authentication. Let's check the hello and dead timers. Do show IP OSPF interface. That's 1040. Do show IP OSPF int. Is it even running over here? Do show IP OSPF int. Do show OSPF neighbor, IP OSPF neighbor. No. So this is telling me that I didn't even have OSPF running on this router, right? So we're initiating the router OSPF on R4. Let's go ahead and save this. Network. And we're gonna activate OSPF on this interface right here. So that's 172.16.4.0, 0.0.0.255. Area, let's do area 0, right? And it should be up now, hold on. Do show IP OSPF neighbor. Should be up, right? What do we have here? Received an invalid packet, mismatch area ID from backbone area, must be virtual link, but not found from 172.16.4.2. Excuse me. So there we have that, right? So this is telling us that something is up. So what is up with this? So do show run. Oh, that's what we have here, right? We have an area mismatch. This right here, this interface, whichever interface this is in area 1. We set it for area 1. They need to be in the same area or nothing's gonna come up like we saw here, right? We have this as area 0. So the problem is really over here because we're doing single area OSPF, right? So we're going to do router OSPF 1 no network 172.16.4.0 0.0.0.255, right? Oops. Area 1. So all of this syslog notifications, they should stop now. And then we're gonna enter the correct command for it, right? So now we're gonna do network 172.16.4.0, and then we're gonna do 0.0.0.255 area 0, right? Now the neighborship should form between these two because their interfaces are in the same area, right? There we go. So what we had here was mismatched area, right? What we had here was duplicate router ID, right? Now we have one more. I think these are fine. Let's check this. Do show IP OSPF neighbor. This looks like it's fine, right? It's neighbors with these two routers, all right? It's neighbors with this router here and this router right here. And we know that because it says neighbor ID and it specifies the neighbor IDs in the in this column right here. This is 8 and this is I must have screwed up somewhere, but it specifies it, right? So it's neighbors with two routers. That should be good. G01 G00, right? So no, that's all good. Yep, that's this one right here because it has a higher router ID. It has the highest IP address on that router as the router ID. I thought I made a boo-boo. But now down here, let's check. Also, we can check right here. You gotta verify. Do show. Now it says that it has a neighborship with this router right here, right? But it's missing a neighborship with this router right here. And just to save time, the issue is that these two interfaces, they're not in the same subnet. So we have to fix that. Do show run. So this is G02, right? G02 says it's in the 172.16.5.0 /30 network, which is not the this is not the 172.16.3.0 network. That is an issue, so we're gonna have to fix that. And how we fix that is simply doing interface G02 172.16.3. Let's make sure there's no duplicate IDs. What is the IP address for that? Do show or show IP in brief. We know that's 3.1 over here, so we're gonna do 3.2. Oops. Yeah, it's time to definitely time to eat. IP address 172.16.3.2 255.255.255.252. No shut, it's already not shut down. Now let's see if it forms a neighborship. Because I have OSPF running on this network. Oh, it's not gonna form the neighborship because I didn't activate OSPF on the interface. So how we do that is, make sure my camera's still good, is we go into router, not exit OSPF 1, and then we're gonna do network 172.16.3.0 0.0.0.255. This is a wildcard mask. All right. Then we can't forget We got to specify the area. So, just a little review. The network command activates OSPF on interfaces that match this right here. This basically says all interfaces that start with 172.16.3 activated, right? Because we have the wildcard mask that says the 0 means make sure you match it exactly. The 255 means doesn't matter, right? We're only focused on these three first numbers. Boom. Now we have the neighborships, right? So that issue was not in same subnet, right? And that is just 4 or 3 of the issues that we can run into with OSPF if we don't make sure that everything is configured properly, right? That's Ospf Troubleshooting, and I think that's pretty much it.